Hello, my dear civil and mechanical engineers. How are you all? What's up? कैसे हैं सब लोग? Please do join me fast so that we can start this wonderful session, which is about the numerical practice or the numericals discussion from the fluid dynamics, which were asked in previous engineering science fluid mechanics paper. So please guys do join me fast, and those who are here, respond me through the comment section if my audio and visual quality are fine. If you can guys hear me properly, please mark your attendance by writing in the comment section so that we can start the session at the earliest. So for those who are attending my session for the very first time, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. Also cleared engineering services examination, which is conducted by UPSC, worked in Steel Authority of India Limited for a couple of years and a private consulting firm also for more than 2 years. And from last 11 years, 10 plus years, I have been into teaching, guiding the students who are preparing for various competitive examination, and I am quite comfortable in fluid mechanics, which is common for civil and mechanical engineers, thermal engineering, heat transfer, as well as industrial engineering. I hope you guys are already part of my Telegram channel. If you have not joined me on the Telegram yet, please do join me on the Telegram, which is Mechanical by Chandrasekhar. The link is also there, and you can either scan the QR code to join me on the Telegram, or you can connect with me through the mail ID. This is my official mail ID. Once you join me on the Telegram, you will be getting these many benefits. The notification of various important examination study notes and PDFs will be provided to you through the Telegram channel only, and the important questions discussion as well as the doubt resolution will also be done through the Telegram channel. Today there will be an important session, the free workshop at 7:30 p.m. I hope you guys have already registered for this mega workshop. If you have not registered it yet, please do it. The link is already there in the description box. It is about the right strategy to crack the GATE 2025 with the best possible rank. So those who are here, please mark your presence. Write something in the comment section if my audio and visual quality are fine. And we are going to conduct a scholarship test on this Sunday between 9 a.m. to 9 p.m. So do attempt this scholarship test, and if your performance is good, based on your performance in the scholarship test, you can get the discounts in our various paid courses. So with our guidance in the right direction and your hard work, you can achieve any milestone the way our previous students had cleared the engineering services examination and made us feel proud with their ranks. So the next chance can be yours. All right, so let us start with question number 1. So the questions are from the dynamics, which will include the ideal flow, that is Bernoulli equation and its application, and it will be the real flow. So including ideal and real flow, we will discuss some important questions which were asked in previous GATE engineering science paper. The difficulty level of engineering science paper is same as that of your GATE ME or CE papers. So it is going to help you a lot in improving your fundamentals, in knowing your level of preparation. If you are able to solve these questions without any support, without any help, it means your preparation is up to the mark. All right. The question says a nozzle has inlet. What is a nozzle? Converging section. The nozzle is having an inlet and outlet diameter. Inlet diameter is D1, outlet diameter is, let us say, D2. D1 is 10 centimeter and D2 is 5 centimeter. If it discharges air, the fluid flowing is air. When we are using the air in case of fluid mechanics, we will assume it as incompressible fluid, right? The discharge of air flow is 0.1 meter cube per second into the atmosphere. The air is discharged into the atmosphere. The gauge pressure, static gauge pressure at the nozzle inlet will be, we need to find out the gauge pressure at 1. Can you calculate the gauge pressure at 1? Can you give it a try quickly? Can you try it? Yes, every one of you, please give it a try. The first equation we are supposed to use is the continuity equation. First is continuity equation, that is the mass conservation, because the flow is assumed to be steady and incompressible and one dimensional. So we can say A1 V1 is equal to A2 V2 is constant. Discharge will remain constant. So we can say D1 square into V1 is equal to D2 square into V2. D1 and D2 are given to us. So can you develop a relation between V2 and V1? Is this the correct relation, V2 and V1? Is this the right relationship between V2 and V1? V2 is 4 times of V1 because D1 is twice of D2. Velocity at 2 will be more, it is 4 times of V1. Then the next equation is the Bernoulli equation between 1 and 2, inlet and outlet. In terms of, we will write that Bernoulli equation is the energy equation in case of ideal flow. If we write the Bernoulli equation in terms of pressure, P plus rho Gz plus rho V square by 2 is constant, isn't it? This is the form of Bernoulli equation in terms of pressure. So can we write P1 by P1 plus rho Gz1 plus rho V1 square by 2 is equal to P2 plus rho Gz2 plus rho V2 square by 2. It is horizontal pipe, there is no change in potential energy. If we take the gauge pressure, we can either take the gauge pressure or the absolute pressure. The gauge pressure at point 2 is 0 because the fluid is discharged into the atmosphere. So we can easily find out P1 gauge. It is rho by 2 into V2 square minus V1 square, isn't it? So that will be rho by 2. V2 is equal to 4 V1 minus V1 square. So it will be 16 V1 square minus 15. So P1 gauge is equal to 15 rho V1 square by 2. This will give you the answer. What is V1? Q is equal to pi by 4 D1 square into V1. From here we can find out the value of V1, 4Q by pi D1 square. Put the value 4 into what is Q? Discharge is given as 0.1. Upon pi, what is D1? D1 is 10 centimeter. So 0.1 meter, 0.1 square. This will get cancelled out. What is the value of V1? What will be the value of V1? 4 upon 0.1 pi. Isn't it? What is the value of V1? 40 by pi. So V1 will be equal to 12.37. Yes, no one, well done. So V1 is equal to V1, you can easily find out. Put the value P1 gauge is equal to the air density is not given. Density of air is not given. But you should have an idea. Density of air is around 1.23 kg per meter cube. Density of air will be taken as 1.15 into 1.23 by 2. V1 you will get 12.37, isn't it? 12.37. Are you getting 12.37 square? That will be in Pascal. So it will be around 1459 Pascal. In case of kilopascal, it is around 1.46. Are you guys getting it or not? Yes? The answer B is correct answer. Yes, well done. Good, good, good. What about others? Question number 2 on your screen. The previous question was asked in GATE 2009. The previous question was asked in 2009. Let me write. This was asked in 2009. And this question number 2, this was also asked in 2009. Can you solve this? Water flows from an open vertical cylindrical tank. There is a cylindrical tank and the water is flowing from the open, it is open from the top of 20 centimeter diameter, capital D is 20 centimeter, through a hole of 10 centimeter diameter. There is a hole which is having the diameter 10 centimeter. D is equal to 10 centimeter. The water is flowing like this. The fluid is water. What will be the velocity of water flowing out of the hole? We need to find out this velocity. What is the velocity of the fluid flowing out of the hole at the instant when the water level in the tank is 50 centimeter above the hole? When the level of water is 50 centimeter. This is, let us say, H, which is equal to 50 centimeter. Ignore unsteady facts. Can you simplify this? This is the free surface. So again, if we apply the continuity equation between 1 and 2, let me call this point to be 1. This is, let us say, 2. So P1 and P2 will be equal. P1 is equal to P2 is equal to P8m. If we take this as reference line, then Z1 is equal to 0 and Z2 is equal to H, that is equal to 50 centimeter. Isn't it? So first of all, apply the continuity equation. Continuity equation. So we can say discharge remains constant. So discharge decreasing will be equal to discharge leaving. Here the velocity is, let us say, V2. Here the velocity is V1. So can we say Q is equal to pi by 4 d square into V2 is equal to pi by 4 d square into V1. Pi by 4 getting cancelled out. Again we can develop a relation. V2 is equal to 4 times of V1. Again here V2 will be equal to 4 times of V1, isn't it? Discharge will remain constant. Discharge decreasing in the tank is equal to discharge leaving from the orifice. Yes or no? So V2 is not taken as 0 because the diameter is not very large compared to small diameter. That is the catch here. The diameter is, capital D is twice of small d. So the V2 cannot be ignored. V1 is equal to 4V2. V1 will come out to be 4V2. Yes or no? Now we apply the Bernoulli equation similar to the previous question. The question is similar to the previous one. If we apply the Bernoulli equation, P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g. Z1 is equal to 0. P1 and P2 are equal. Our objective is to find out V1 square. So we can say V1 square minus V2 square by 2g is equal to Z2, that is H. So V1 square minus V2 square is equal to 2gH. And what is V2? V1 is equal to 4V2. Let us put V1 is equal to 4V2. So 16V2 square. Can you simplify this? Minus V2 square is equal to 2gH. So V2 is equal to under root of 2gH upon 15. And what is V1? V1 is equal to 4V2. So it is 4 under root of 2 into 9.81, or let me call it as 10 into H 0.5 upon 15 meter per second. That is the value of V1. How much is that? कैसे करेंगे क्रेजी मीटर? because diameter are not, वो तभी √2GS तभी लिखते हैं where area of the tank is very very large compared to area of the, when area of the tank is very very large compared to area of orifice, then we can say velocity in the tank is ignored, it can be taken as 0, then we can say velocity v1 is equal to √2GH, वो तभी होता है, but because area of the tank is not very large, so how much is that, कितना आ रहा है, 50/15, sorry 10/15, 2/3 under root into 4, 3.2659. Are you getting 3.26? Are you getting 3.26 something? 3.26. B is the correct answer. B will be the right answer. Something around 3.26. B will be the correct answer for this one, right? The next question, question number 3. Try to solve the next one. Did you understand the question? This question was asked in 2010. This question was asked in 2010. A 20 centimeter diameter pipe carries water discharge of pi by 100 meter cube per second. The pipe is bent through an angle of 30 degree in the horizontal plane as shown in the figure. Neglecting friction, the component of force exerted by the water, the force which is exerted by the water on the bend section in x and y direction will be. So if you take this as the control volume before the bend and after the bend, this is taken as our control volume. This is our control volume, isn't it? This is under observation. Due to bend, there are forces developed and the fluid will exert, the water will exert a force on the walls of the pipe in normal and compressive direction. The force exerted by the water is normal and compressive, like this. This is the direction of force exerted by water. And due to curved streamline, there are curved streamline. For the curved streamline, do you agree pressure at 1 is less than pressure at 2? In case of curved streamline, pressure on the inner walls will be less than pressure on the outer walls, and area due to contraction or due to bend A1 is less than A2. So the force F1 will definitely be less than force F2. This is force F1 by the water on, this is F1, this is F2. So F2 is greater than F1. So the net force will be like this. The net force by the water, F by water, the force by the water on the bend is in this direction. So it is in positive, its component is in positive x direction and another component is in negative y direction, isn't it? There are two components of force by the water. One is positive x, another is negative y. So positive x and negative y can only be correct. Negative x is incorrect and both positive is also incorrect. B and D cannot be correct. B and D cannot be correct. It is either A or C, isn't it? Now we need to calculate the magnitude by using the momentum equation. We can say here, if we calculate the momentum equation, this is section 1, let us say, this is section 2, this is our control volume, this is our control volume. So we can say area at 1 is equal to area at 2. So V1 is equal to V2, there is no change in velocity, and Z1 is equal to Z2 because it is in horizontal plane. So we can say according to Bernoulli equation, P1 is equal to P2. That is the Bernoulli equation. Bernoulli equation. Now if we assume Fx and Fy, Fx and Fy are forces on the fluid. So forces on the pipe will be, force on the pipe will be like this, and force on water will be like this. Force on water. So force on water will have two components, one is Fx and another will be Fy. So Fx and Fy are forces on water in X and Y direction respectively. So if we apply the momentum equation, if we write the momentum equation, first of all let us write the momentum equation in X direction for the water. This is our control volume. So P1A1 will be acting in X direction, P1A1, then minus Fx force on the water, then P2A2 component minus P2A2 cos of 30 is equal to rho into Q, density to discharge, into change in velocity, because we are writing the momentum equation for the water. So final velocity V2 cos 30 minus V1. P1A1 and P2A2 are equal, both are 0. P1 gauge is equal to P2 gauge is equal to 0. So we can say Fx will be equal to rho into Q into V 1 minus cos 30. Yes or no? Rho QV into what is V? V can be written as 4Q by pi d square. So rho Q 4Q upon pi d square into 1 minus cos of 30. Can you solve it? Cos 30 is under root 3 by 2 kya? Can you solve it and let me know the answer? Can you find out the value Fx? Discharge is given, density is 1000. So if you are able to calculate Fx, diameter is given as 20 centimeter. Put the values, you will get the answer. Put the values, you will get the answer. Can you solve it? Are you getting 4.21 Newton or not? Are you guys getting 4.21? 4.21 Newton. So Fx will be 4.21. So that is why C is not correct. A will be correct. Similarly, you can write Fy. This is Fy in Y direction. So the component of P1A1 in Y direction is 0 plus Fy. Then component of P2A2 will be in negative minus P2A2 sine of 30. Sine 30 is equal to rho into Q into final velocity is V2, initial velocity is V1. So V2 sine 30 minus 0, initial velocity in Y direction is 0. This is the momentum equation in Y direction. This is how we apply the momentum equation in Y direction. We can easily calculate Fy. This will be 0. So Fy is equal to rho into Q into V into sine 30 or 10 to the power 3 into pi by, what is discharge? Pi by 100 into 4Q by pi d square, 20 centimeter, 0.2 square into sine 30. How much is sine 30? Actually, velocity will come out to be 1 meter per second. Velocity will come out to be sine 30 is 1 by 2. So this will be Newton. Are you getting Fy to be 15.71 Newton? If you calculate the velocity, that is 4q by pi d square, then you will get is 1 meter per second. So instead of writing v as 4q by pi d square, you can take v as 1 meter per second as well. So that is why the correct answer is option A. A will be the answer. Yes, no one? Well done. Good, good, good. What about others? Do you guys understand how to write the momentum equation? I hope you understood how to write the momentum equation. The next question on the screen. इस क्वेश्चन का जवाब बताइए. If you have any doubt in writing the momentum equation, please do let me know. Now do let me know. There are air from the blower of a hair dryer flows between two identical elliptical cylinders suspended freely. They are like balloon. For two cases shown in the figure, the cylinders would move. In first case, this is case 1. Here the balloon 1 and 2 are kept, and in this case balloon 1 and 2 are kept in second case. There is an airflow. So which will be the correct answer for this one? What will be the answer? Yes, everyone. I am waiting for your answer. Waiting for your answer. No one is saying option D. Towards each other for case 1 and towards each other for case 2. Here are options. These are the options. What will be the answer? Is there any difference if the cylinders are kept in different orientation? Hi Shayad. Welcome. Good, good. D. Crazy Meteor is saying B. Let me tell you, when the cylinders are kept like this, there is a gradual decrease in area. When the elliptical cylinders are kept like this, in case 1 there is a gradual decrease in area, and when there is a gradual decrease in area, if the area decreases, then the velocity will increases, and if velocity will increase, then the pressure will decrease. That is the Bernoulli principle. We can apply Bernoulli principle or Bernoulli equation. So between the gap, the pressure will decrease. So here, if I call this pressure to be P1, and if I call the pressure outside to be P2, so we can say P1 will be less than P2. So in case 1, area decreases, velocity increases, so pressure will decrease. So pressure P1 is less than P2. So the ellipse will move towards high to low pressure. There will be force developed from high to low pressure. So there they will be moving towards each other, isn't it? But here, if the ellipse are kept like this, then there is a sudden convergence. There will be sudden convergence like this. So whenever the fluid strikes here, then due to sudden convergence, the area will decrease suddenly. Or we can say the fluid will strike here, the velocity will decrease. Momentum transfer. This is from the momentum transfer. due to sudden convergence, there is a momentum transfer to the balloon. Whenever there is a momentum transfer, velocity of the air will decrease. The air will strike on the balloon, the velocity of air will decrease. When the velocity of air will decrease, pressure of air will increase. So we can say here P1 will be greater than P2. P1 will be greater than P2. So there is a force acting which will move the balloon in outward direction. It will move the balloon in outward direction. The first case is about the energy conservation, Bernoulli principle. The second is due to momentum transfer. Are you getting it? In first case, the pressure will decrease between the cylinders. In second case, pressure will increase between the cylinders. So in first case, pressure will decrease. In second case, pressure will increase. Why the pressure will increase? Because in second case, velocity will decrease. It is like a pitot tube. If there is a restriction in the flow path, the fluid will strike to the restriction and the velocity will decrease. It will transfer the momentum, isn't it? And there will be an increase in pressure due to kinetic energy getting converted into pressure energy. I hope that is clear. Please give me yes. If this is clear to everyone, please do let me know. Only Crazy Meteor had given the correct answer. The second case is the kinetic energy of the fluid getting converted into pressure energy. So pressure of air will increase in second case between the cylinders, but in first case the pressure will decrease due to gradual decrease in area. The next question. Next one. This question was asked in 2009. Read the question. Linked question. There are two questions, 5 and 6. An incompressible fluid is passed through a T junction. Here the incompressible fluid is passed, supported on the wheels. The junction is supported on the wheels as shown in figure. The area at outlet A is twice that of outlet B. Here the area is twice. AA is twice of AB. That is given. Area at A is twice of area at B. While the incoming mass flow rate A is fixed. Q is constant. Discharge is constant. Whatever the mass flow rate entering into the T junction is constant. It is fixed. The distribution of flow at two outlets can be varied by suitable mechanism built in the system. Assume that the flexible tube offers no resistance to the motion and frictional effect in the pipe and the wheels can be neglected. Now consider the following two cases. In case 1, the flow rates at section A and B are equal. In case A, the flow rates are equal. It means QA is equal to QB. That is constant. Q is constant. In first case, QA is equal to QB, that is Q is constant. Yes or no? The flow rate QA is equal to QB is equal to constant, we can call it as Q. Discharge remains constant in both the tubes. And in second case it is saying the velocity at section A and B are equal. VA is equal to VB is equal to constant, that is V. The velocities are equal. In second case, the velocities are equal. In first case, the discharge are equal, isn't it? Do you understand it? Now question number 5 on your screen. Now there is a question. Which of the following statements are true? In case 1 we know discharge is constant. In case 2 we know velocity is constant. So in case 1, the velocity at section A is twice the velocity at section B. And in case 1, the velocity at section A is half of the velocity at section B. Out of P and Q, only one is correct. Out of R and S, only one is correct. P and Q, one option is correct. R and S, one option is correct. Bataiye. Can you give it a try? And please guys, do not forget to like and share this session so that the session reaches to all the students who are preparing for GATE 2024 or any other PSU examination. Yes, I am waiting for your answer. If we talk about case 1, if we talk about case 1, discharge, that is area into velocity, is constant, isn't it? So we can say V is inversely proportional to area. In case velocity is inversely proportional to area, more area, less velocity. Less area, more velocity. Velocity is inversely proportional to area. So the velocity at A will be less than B. Velocity at A is twice, that is incorrect. Velocity at A is half, that is true. Isn't it? Q is correct. In case 1, velocity is inversely proportional to area. If area increases, velocity decreases. So velocity at A will be less than velocity at B, isn't it? Velocity at A will be less than velocity at B. If we talk about case 2, in case 2, velocity is constant. If the velocity is constant, means discharge is directly proportional to area. Discharge will be directly proportional to area. If area increases, discharge also increases, yes or no? So more is the area, more will be the discharge. QA will be greater than QB, yes or no? More will be the area, more will be the discharge. So in case 2, the flow rate at section A is twice. Definitely correct. Flow rate of at A is half. No, the flow rate will be directly proportional to area if the velocity is constant. So it is Q and R. अच्छा ये Q है. C and R means Q and R. This is Q actually. This is Q. Isn't it option C? Isn't it option C? Yes or no? Option C is the correct answer. Yes or no? The next part of the question. The next question. Which one of the following statement is true? The next part is about the momentum equation. The system will move to the left, the system will move to the right. In case 1, if we talk about case 1, Q is constant. In case 2, V is constant. So the change in momentum of the fluid will decide what is the momentum per second. That is rho into Q into V. That is the momentum flow rate. So if we talk about momentum at A, if we talk about case A, for case A, if we talk about case A, Q is constant. So the momentum is directly proportional to velocity, isn't it? In case of 1, the momentum flow rate is directly proportional to velocity, density is constant, and Q is constant. So momentum is directly proportional to velocity. So we can say VB is greater than VA, yes or no? So P dot B is greater than P dot A, yes or no? P dot B. So the more is the momentum flow from B, less is the momentum transfer at A. So momentum flow is less in A and more in B. It means the force on the fluid will be in this direction. Force on the fluid will be in the direction of increasing momentum. So force on the system will be, according to Newton's third law, force on the system will be in negative x direction, yes or no? So in case 1, the system will move to the left, isn't it? In case 1, the system will move to the left. Are you getting it or not? And if we talk about case 2, V is constant and momentum flow rate is rho QV. So we can say P dot is directly proportional to Q. And as QA is greater than QB, isn't it? So P dot A is greater than P dot B. Momentum at A is greater. So the force on the fluid will be in this direction. According to Newton's third law, force on the system will be equal and opposite in this direction. So in case B, it will move towards right. In case 2, the system will move towards right. P and S. P and S. There is no P and S. कुछ गड़बड़ हो गया क्या? P and S. There are no option. No option is there. P and S. कुछ ना कुछ मिस्टेक हुआ है. यहां तो P और S होना चाहिए था. ये P और Q एक साथ हो नहीं सकते. P and Q cannot be together. Both P and Q cannot be correct simultaneously. Both R and S cannot be correct simultaneously. D. क्यों नो वन? देखिए, अगर फ्लूइड का मोमेंटम इधर ज्यादा है P.1 और इधर फ्लूइड का मोमेंटम कम है P.2, इफ P.1 is greater than P.2, then the fluid will have a momentum or force is the rate of change of linear momentum. Change in momentum flux is the force. F is equal to the force exerted will be equal to rate of change of linear momentum delta P dot, isn't it? The force exerted is the rate of change of momentum. If P.1 is more than P.2, then the force on the fluid will be in this direction. Then only the momentum increases. Force on the fluid. Yes or no? Are you getting it? So in case 1, the system moves to the left, and in case 2, the system moves to the right. Do you get it or not? Is this clear or not? Please do let me know. Option D गलत लिखा हुआ है, because P and Q together cannot be simultaneously true. P and Q cannot be simultaneously true. Similarly, R and S cannot be simultaneously true. So it is PR, PS and QR and QS. They should be the options. We are running some quizzes on our BYJU'S app also. If you have not started attempting the quiz on the BYJU'S app yet, or if you have not downloaded the BYJU'S app yet, start downloading it now using the bit.ly link which is already there in the description box. Once you download it, you can attempt the quiz as well. Newton's third law, Syed. For every action there is an equal and opposite reaction. If the fluid, this is the pipe, let us say, this is the pipe. If the force acting on the fluid is like this, if force acting, this is the fluid, this is the fluid. If the force is acting on the fluid like this, then the fluid will exert a force on the pipe in backward direction, isn't it? The fluid will exert a force on the pipe in backward direction. Newton's third law, for every action there is an equal and opposite reaction. So the magnitude of forces will be equal, but the direction will be opposite. One is the force on the fluid, another is the force on the pipe walls. Are you getting it? That is called as Newton's third law. I hope this is clear. Let us move to the next one. Question number 7. The next question on the screen. Question number 7. This was asked in 2011. This question was asked in 2011. Can you solve it? The question is from the pitot static tube. Pitot static probe is inserted in an airflow A manometer connected to this probe having mercury as the manometric fluid shows a difference of 30 mm. That is the manometric fluid deflection x. Assume the probe factor, that is the coefficient of velocity, probe factor of 1. Assuming density of air, this is density. Assume the density of air to be 1.23, density of mercury to be 13,600 and g as 10 meter per second square. The speed of airflow is approximately, can you solve it? The velocity is given by Cv under root of 2gh, and what is h? Where h is equal to Sm by Sf minus 1. So if you put the value, Cv is taken as 1, so the velocity will be equal to under root of 2gx. Either you write density of manometric fluid, density of flowing fluid minus 1. So put the values, you will get the answer. It is simple. Put the values, you will get the answer. X is the manometric fluid deflection. 2 into 10 into x, 30 mm, 0.03. 13,600 upon 1.23 minus 1, that will be meter per second. What is the answer? What will be the answer? The approximate value. Are you getting around 81.5 meter per second? I hope you are getting 81.5 meter per second. B is the correct answer. Well done. B will be the answer. Question number 8. Simple. The next one, question number 8 on the screen. When a large tank containing water is placed on a weighing scale, this is the weighing scale. A reading of 10,000 Newton is obtained. Now the tank is fitted with an outlet pipe. This is the outlet pipe. And a valve as shown in figure. When the valve is opened, a jet of water with a velocity of 10 meter per second issues out in the vertically upward direction. When the valve is opened, there is a jet coming out in upward direction. The diameter of the outlet pipe is 10 centimeter, that is D. Determine approximately the reading on the weighing scale at the instant the valve is opened and the water jet issues out. Density of water is 1000 kg per meter cube. When the jet issues out, then there is an increase in momentum of the jet. Initially the velocity of jet was 0 and the final velocity is v. So there is an increase in momentum. So there is a force exerted on the jet in this direction, that is equal to rho into q into v, isn't it? Rho qv. That is the force on the jet, and according to Newton's third law, when there is a force exerted on the jet in upward direction, there is a force exerted on the tank in downward direction, that is equal to f jet. So the force exerted on the tank plus weight of water will be the total reading of the weighing machine. The total reading of the weighing machine will be reading of the weighing machine, or we can say W net is equal to W of water, weight of water, plus rho qv, or we can say this is 10,000 Newton plus density is 10 to the power 3, q is pi by 4 d square into d square into v square. What is the velocity? 10 meter per second. So it will be 10 square. So these two will get cancelled out. Yes or no? So it will be 10,000 plus 1000 pi by 4 Newton. What is the reading of the weighing machine? The net downward force will be the reading of the weighing machine. 1000 pi by 4. $785.4. 10,000 plus 785.4 Newton, or 10 785.4 Newton will be the net downward force. That will be the net downward force. 10,000. It is more than 10,000. It will be more than 10,000. A cannot be correct, B cannot be correct. It is more than 10,000. So it will be 10,785. 10,785, right? C will be the answer. This is simple. Question number 9, 10. Question number 9 and 10. Try to solve this one. A two-dimensional rectangular water jet of velocity 10 meter per second. This is the rectangular water jet. The nozzle is rectangular like this. So the water jet is coming out in rectangular shape. Velocity is equal to 10 meter per second and the area, jet area is equal to 5 centimeter square. Impinges normal to the flat plate. This is the plate and it splits symmetrically into two half jets, Q1 and Q2. This is, let us say, Q. So Q1 is equal to Q2 is equal to Q by 2. Yes or no? They will be equal. From the mass conservation or continuity equation, discharge entering will be equal to discharge leaving. Q1 is equal to Q2 is equal to Q by 2 because they are symmetrical. Each of area 2.5 centimeter square. So A1 is equal to A by 2 and A2 is also equal to A by 2. A1 is equal to A2 given. A1 is equal to A2 is equal to A by 2. So if we write Q1 is A1 V1 is equal to A2 V2 is equal to Q, that is area into velocity by 2. So A1 is equal to A2, that is A by 2. This will get cancelled out with this. So do you agree V1 is equal to V2 is equal to V? The velocity will remain same. After splitting, the velocity of the upward half jet along the plate is, there is no change in the velocity. There is no change in the velocity. Velocity will remain same. There is no change in pressure. There is no change in potential energy. So according to Bernoulli principle, there is no change in the kinetic energy of the fluid. The velocity will remain same. 10 meter per second. The magnitude of the reaction force at the wall is, the force exerted on the plate will be the force, reaction force. So force is equal to rho QV minus 0 in x direction. So it will be rho into pi by 4 d square into v square. Put the value 10 to the power 3 pi by 4. What is the diameter? Diameter is 5 centimeter square. Into v square. What is the velocity? 10 meter per second. This will be the force. Sorry, area is directly given, na? This is A. It is area directly given. The area is 5 into 10 to the power minus 4. So how much is that? Area is 5. V square. So it will be 50 Newton. It is V square. Isn't it 50 Newton? 50 Newton will be the answer. 50 Newton. Next question, please give it a try. Question number 11. Solve question number 11. This was asked in 2009. Find the answer for question number 11. Everyone, please give it a try. Consider a fully developed laminar flow. The flow is laminar in a circular pipe. If the diameter of the pipe is halved, if the diameter, that is where students commit the mistake. Please check, crazy. If the diameter of the pipe is halved, D2 becomes D1 by 2, while the flow rate and the length remains constant. The head loss increase by a factor. So we need to develop a relation HL and diameter. The objective is to develop a relation between HL and diameter. We can use Darcy-Weisbach equation. We can use Darcy-Weisbach equation. HL is equal to FLQ square upon 12.1 D to the power 5, isn't it? Length is constant, discharge is constant, 12.1 is constant. So what we will get, HL is proportional to F upon D to the power 5. But do you know, for laminar flow, F is equal to 64 by Reynolds number, because it is a laminar flow. For laminar flow, this is equation number 1. For laminar flow, F is equal to 64 by Reynolds number, or 64 mu upon rho Vd, isn't it? 64 is constant, mu is constant, density is constant because it is water. So F is inversely proportional to V into D, and discharge is constant. Q is equal to pi by 4 D square into V is constant. So V is inversely proportional to D square, isn't it? If you put the value V is inversely proportional to D square, then we will get F is directly proportional to D. And if we put it here, then we will get HL is inversely proportional to D to the power 4. Yes or no? You will be getting HL is inversely proportional to D to the power 4. Either use this concept, or you can use Hagen-Poiseuille equation. Because for laminar flow, we can use Hagen-Poiseuille equation. HL is equal to delta PL by rho G. That is 1 by rho G, 32 mu VL by D square. Rho is constant, G is constant, mu is constant, length is constant. So we can say HL is proportional to V by D square, isn't it? And Q is equal to pi by 4 D square into V is constant, discharge is constant. So we can say V is inversely proportional to D square. If you put this value, here, V, so what we will get, HL is inversely proportional to D to the power 4. So we can say HL2 by HL1 is equal to D1 by D2 to the power 4. What will be the answer? So head loss will increase by a factor of 16, isn't it? Isn't it 16? 16 will be the answer. That is how the questions are framed. 16 will be the answer. D2 is equal to D1 by 2. D2 is equal to D1 by 2. So it will be 2 to the power 4, that is 16 will be the answer. So that is all from my side. I am giving you one assignment question. This is your assignment question. Try to solve this question at home and share me the answer to my Telegram channel. And I will share the PDF of this session to my Telegram channel also. And next session will be on Friday at 5 p.m. We will be meeting again at 5 p.m. on Friday. At the same place on the YouTube, I will discuss about the best utilization of remaining period for your GATE 2024 preparation. So do not forget to join me day after tomorrow at 5 p.m. Alright. We are running mega mock test also for the various for the GATE 2024 aspirants. So do attempt this test as well. Based on your performance in the test, you can unlock our test series also at discounted prices, very cheap prices. The links, important links, are already there in the description box. We are running the paid courses also. If you are preparing for 2025 or 2026, you can join our paid courses to get to have more chances of getting the selection, or to have better chances of your clearing the gate or any other competitive examination. This is my mail ID. You can connect with me through the mail ID, or you can join me on the Telegram, which is Mechanical by Chandrasekhar. All right. So this is all from my side, guys. Thank you very much for joining in. Do like and share this session. See you in the next such session. Till then, enjoy. Take care. Have a good day and a great career ahead. Jai Hind and take care.